Wallahi, I do not totally interfere with the exam. I'm not from the exam committee. أنا مش في لجنة وضع الامتحانات. والآن طلبوا مني أجي أصور قلت لا ما بدي أصور ولا أشوف الامتحان أبدا. ليش؟ For a reason. When I give my expectation, this is what I expect from the questions. When I say, for example, you have a problem in Bernoulli's equation. I ask you, what type of problem? I don't know. To be honest, I'm saying about this one. We need just here to tell you how to prepare for the exam. We're not going to tell you what is the exam. And honestly, I'm not here. I don't have any idea what is the questions. Inshallah, بتوقع إنه there's some female section, someone who stick his nose in the exam, so I suspect it will be lower level, not the 8. So this is, we are ready for any of you this week and next week also for any question you have it. I prefer all the students, you just focus mainly, of course, in the textbook, what is the problem, solve in the textbook, and what the problem actually we put it as a homework for you. My idea, all the question will be around these ideas, not more than that. Nobody will ask you, Shabab, something very far. Some students yesterday, they told me something about the density and volume of two different gasoline and water. There's a question in D here. But to be honest, in that one, nobody will ask about the volume and density and leave Bernoulli's, Boyle's equation, blah, blah. All these are important. You try to predict which is important for you. And you have to be familiar with it. This is what I talk about it. So inshallah, you have to prepare within that. Let's start before till this work. See, first of all, in the last time, if you remember, we stopped at the human hearing range, which is start from 20 hertz till 20,000, right? Hertz. This is we call by the human range, that hearing for the human range. We said also, Shabab, below this we call by infrasonic, and above this we call by ultrasonic. And clearly that the word infra means below, beneath, and the word ultra means above of that one. This is actually audible range for us. We can hear all the sound that range the frequency from 20 to 20,000. Above that or below that, we will unable to detect normally. We can detect by using some devices. Yes, but normally we are unable to detect that, okay? This is the hearing. Now, I'm gonna just start with the point thing. When we talk about the sound waves, Shabab, here, sound waves actually has some properties. One of the properties of the sound, which is called by the ear, I told you to, pitch of sound. Here, the word pitch of sound, it means the frequency of the sound. All of us, we have different frequencies because all of us, we have different sounds, right? Just like all of us, we have different frequencies on our mobiles because all of us, we have different numbers, right? It's impossible to find two, they have the same number. And there's nothing on, maybe our sounds close between brothers and relatives, okay? But even though it is, there's some difference between them, okay? So, I want to say something here. Pitch of sound is something for compare between one person and another. Compare between one sound and another. So this is here depends on frequency, mainly. And you start to say, more frequency is called by highly pitched sound. Highly pitched sound. Just like the sound of the girls, sound of sometimes birds, just like that. And lower frequency is actually lower pitched sound. In Arabic we call it ايش شباب؟ صوت يعني حادة عالية وحدة عالية وحدة ايش؟ منخفضة. This is one property. The second property we talk about is the loudness. Now we will talk about this. Oh, the loudness. This is about your sound. Sometimes you can talk quietly. Sometimes you can talk shouting. صح يا شباب? So this is different now. This was to compare between two different sounds. This one for only one sound. That sound could be either quiet, صوت هادي يا شباب, or could be actually louder. Okay? Now I need just here to give you this idea then. Quiet, this depends يا شباب here on the amplitude. Amplitude. It means more amplitude, louder is the sound. Less amplitude, quieter is the sound. If you compare, this is the sound for the same source, ya shabab. I'm going to show it to you. See, if we have this sound, انظر بارك الله فيك, and we have this sound. This is for the same person, but this one we call it quiet because it's less amplitude, and this one what? Louder, صوت عالي. We have, sometimes we whisper, نهمس لبعض, صح? Sometimes you shout. And this is, I need to start with it. About the frequency, I told you about this. This is for same person, as I said, same source. Now, in the frequency, no, we have different sources. The source one has this frequency as an example. The source two has different frequency. You remember? We say this is, for example, this is the sound that we expect for a woman as an example, and this is the sound for man. This is highly pitched sound, this is lower pitch. Is that clear? Barakallah feekum. طيب, we will start from this one now. Loudness. By the way, Shabab, when you start shouting, you're producing a lot of energy. That's why sometimes you feel exhausted after fighting with someone. صح? Even if your fight is only sounds, not more than that. بس الصراحة ما كان فيها ضرب يعني. Even that you feel that exhausted. Why? Because you now use what you simply you produce a large amount of energy in the form of sounds, and this large amount is actually make your body to become tired and you feel exhausted. Now we will study this here, the relationship between the energy sound of the sound and something like that, how we describe it. So we will introduce something for you, it's called by the intensity of sound. Follow me, Shabab. Intensity of sound. This is we call by شدة الصوت يا شباب. ديروا بالكم هذا loudness معناه ارتفاع الصوت. This is related to the energy. Simply, intensity of sound is the power over area. The power of the energy over area. So we say, Shabab, this is I, intensity is equal to the power over area. And the power itself, we took it is equal to energy, remember that? Over time, over what? Area. Because the power itself, what? Energy over time. You remember this? So how much energy, or the rate of energy transfer is the power. How much the power simply penetrate a certain area, this is the intensity of sound. How is it? See, if you have this area, small area, and you have this large area, and you are producing some sounds. These sounds the same. تفضل. My idea, Shabab, whether here this sound energy will have the same influence here in the small area, just like the bigger area.
No.
So which has more influence now? Smaller one. طبعا يا شباب. Now, if you have here, you have this. We expect that your sound energy is the same. So if you shout in something very small, you can cause what we call by here. Just like sometimes if you blow on something very light, لما تنفخ على شيء خفيف بتحرك. طيب يا أخي انفخ على الجدار. Right? This is the same thing we have it. The amount of energy over this small area. See, if the area is small, what the intensity will be? High. According. And here, if the area is large, what about the intensity?
Low.
Will be low. So this is Yeshua, we introduce it for you. It's called by the intensity of waves or sound waves. Now we will see, this is what is the units of each of them, and we proceed. Because here we have something very important about this relation. Shabab, pay attention now. If I say what is the unit of I, the intensity, I intensity is nothing but power over, so the unit will be watt per meter square. And the watt itself equal joules per second. So in other words, you can say joules over second meter square. Is it the same? Yes, because watt is equal to joules per second. This is an idea. Okay, now let's start with this one. If you remember, we explained this last time. Okay. So, this is the energy and intensity I'm talking about. We say traveling wave transfer energy from one point to another. The power of the wave is the rate at which the wave transfers energy. Finally, the intensity, which we explain it, of the light or sound wave, is the power of the source and the area that receive the power. So it's I is equal to B over A. This is called the intensity of the wave, either the light wave or sound wave. Okay, Shabab? This is the idea. This is the area and this is the wave that we expected. Now, there's something related to that one. Why we studied this, Shabab? To show you something. I'm sorry, this is not working. Time is not available. Why we study this one important? What's actually relative here to your medical applications is, by the way, the intensity of sound. If you have some patient, Yeshba, you don't care about his sound, whether his sound is good or his sound is bad. You care about whether he can talk, he can produce the sound, or who can hear the sound. صح? You don't care about what is the pitch of the sound of your patient. He's not a singer or not a rock star, whatever is it. انت بيهمك المريض لما يجي ما بيهمك صوته. والله تقول له غني لي. انت بدك تفهم انه بيحكي وانه بيسمع صح؟ So what you concern about this is, you don't concern about 20 hertz هذه. This is, you are, as a physician, you don't concern about it. This is the frequency. You concern about the intensity. Whether your patient is actually capable of hearing the sounds, the intensity, the lower one. That's why sometimes, you know, some patients, they have what we call by the earphone to amplify the intensity, to simply increase the intensity. So this is here. Loud, we say that loudness of the sound is measured by a quantity called by the sound intensity level. Now we need this formula, see Ishbal. There's a formula that sound intensity, beta, is equal to 10 log I over I naught. Pay attention to me. This is a problem. This is sound intensity level. Sound intensity level measured in a unit called dB, decibel. This is what you concern about as a physician. هذا بيهمكم يا شباب كأطباء. لما تقيس لمريضك الحالة. Now this is 10 is okay, we know that. This is and log is an arithmetic operation. This is sound intensity. And this one, I'm going to explain. This is the threshold sound intensity. You know what is the threshold? It's the minimum sound intensity that the human being can detect. In Arabic, we call sometimes the threshold بسموه العتبة يا شباب. عتبة هو أول البيت صح؟ أول sound intensity for the human that can hear is called the threshold. The threshold for hertz, how much is it? 20. By the way, suppose 19 you are unable to hear, right? But 20 is the threshold. Here you have this is, and here I0 is the threshold. And by the way, it's constant. See, it's 10 to the power negative 12 watt per meter square. This is constant for all the people. So this is what I'm saying about it. Now, you have two things here to detect. By the way, this is given, is a constant for all the people. You can either find I, the sound intensity of your patient, or you can find the sound intensity level of your patient, beta, according to this one. So now, if we have your patient has the same, we can say the sound intensity level in the normal range, he can hear properly. Otherwise, you have to give him just like just like this glasses, you have to give him something to prepare that loss of intensity. You got the point now. And I want to say something. All the earphones, they are designed for a particular persons. Just like the glasses يا شباب. السماعات ما تعطى السماعة بس لأي واحد. هذه السماعة الطبية تصمم لشخص واحد فقط. You got the point. Because that defect is different from one person to another. Just like the glasses. This will help you to do that. To detect whether your patient he needs which type of the earphones and what is the level that he needs. Okay, barakallah feekum. Now, here there is some problem I need to explain before we proceed. Sometimes, ya shabab, you should know how to deal with the logs. And this is a problem in calculations. I need just to explain something. If I ask you to find I, here, what is inside the log? As an example, if I give you here, beta is equal to 60 dB, and you know I naught is equal to 10 to the power negative 12, find I. Follow with me, how we find this simple I. We write the equation and we say 60 equal 10 log I over 10 to the power negative 12. Okay? What I'm saying, Ishbab, there are many properties of the log. That's why I just advise you to follow this one. I know some people, they say, okay, can we say log I minus log 10 to the power negative 12? Yeah, this is one approach, but there's something easier. Don't go to we can say, longest way. Now you need I. What you do first of all, get rid of 10, right? So I'm going to say 6 equal log I over I 10 to the power negative 12. Okay, barakallah feekum. Now remove log in simple way. How? You write by actually power this to the 10. You write 10 to the power 6 is equal to I over 10 to the power negative 12. Is that point or step is clear for you, Shabab? We remove the log and we put this one here. Just like this is property of the log. Shabab, the can log x is equal to 5. Okay? You know what is x? It's 10 to the power 5. That's simple. We remove this, we put this to the power of 10 because this is, we call pi, it's a decimal log. This log is a decimal log. هذا بسموه logarithm عشري. There is another log which is called ln. صح? That one natural. We use this one, inshallah. This is sometimes they put subscript here 10. So, is that clear for you? Because you have a problem here, inshallah. You will see that. You have sometimes some problems. Some people said, oh, we try to find log I, then minus log negative 12, then we send. This is a long way for the solution. والله راح يكون طويل يا شباب. Finally, you have the same problem. We have to get rid of log. صح? طيب. If you do this, if you want to find beta, do it like this. It's 10. Log, then open bracket. I divided by 10 to the power negative 12. In this sequence here, Shabab. Because you have to. Because sometimes this equation or this here is very important, but you should know how to extract either I or beta as we mentioned. Okay? Now we'll see together some problems in these. But just a moment. Here, if you watch me, Shabab, here. This 10 is not 10. This is a subscript. العشرة الصغيرة هنا شايفينها؟ That's why I try to look. هذه 10 log، هذه 10 subscript. تكون رقم صغير. ما في داعي انتم تعرفوا في الماث اخذتوا هذا الشيء. اللوج يا شباب ال LOG هذا to the base 10. ال LN هذا بيسموه natural. شوفوا آلتك الحاسبة موجودة فيها. اثنيناتهم صح؟ So this is, we use the first one. Okay, barakallah feekum. And this is I naught, as I said, is 10 to the power negative 12 watt per meter square, as we mentioned. Now, let's see some examples on the intensities. Then we proceed. First First of all, see يا شباب, the threshold of hearing is 0. Oh, you know what is 0 now? You know, when I say 1000 hertz, at what, here we can say, at what intensity will be, I will be, how much? So that intensity level will be 0. Hi Shabab, we have beta is equal to 10, see, log I over 10 to the power negative 12. Yalla barakallah feek. This is simply, how much this one here, to be, for this one to be 0. How much I should be? 0? No, this is 1000. Ya Shabab, if I ask this question, log 1, how much is it?
10.
Haram.
0. No.
0. You have your calculator, I can prove it for you. تعالوا معي. Log to the power 10 صح؟ اكتب 1 is equal to 10 to the power. صح ولا لا؟ It's 0 يا شباب. 10, any number to the power 0 is 1. Right? So this is, you should know, to make this يا شباب here 0, what you have, this numerator should equal the denominator. This, all terms should be 1. Because log of 1 what? 0. So this is the threshold. This is the beginning. And if you say this is now all of this 0 here, we have that here, the threshold of the hearing. See, I will give you just examples. 30 dB is for a quiet home. This is something here, of course, an average. We have 60 is normal conversation. Now we are talking, which is our intensity level is in the form of 60 dB. Now watch usually. 90, for example, inside a heavy truck, damage from prolonged exposure. You are inside a heavy truck. Now 120, for example, loud rock concert, here chipper or threshold of pain. Finally 140, which is the top, jet airplane at 30 meters. So this is will cause a lot of damage to your ears, right ya shabab? So you know that in some factories, some airports, all the people who work, they have what we call by ear protection. لازم يحموا أذانهم صح ولا لا؟ This is it. So these levels, that's what we deal about. Your job يا شباب to know, for example, if your patient, he's a young man, he can, for example, he can hear all the sound within 30 dB. But if he's an old man, you expect, oh, can he, okay, he can sit till 40. Because we know that old men, they have problem with the hearing with age, right? So this is your problem. You have to measure, you have the device to measure what we call by the sound intensity level for your patient. بعض الأصوات يا شباب، إحنا زي ما نقول مثلا باللغة العربية، واحد ما شاء الله عينيه زي الصقر، واحد يقول والله يسمع دبة الإبرة إذا سقطت. صح؟ Why? Because this is something actually we can say relative. هي يعني تختلف من شخص لآخر. Your job, if you have a patient, your job is to do what? To examine him with something that is normal. أنت ما راح تحطه في المطار جنب طيارة تقول له بتسمع ولا ما بتسمع. راح تطير دنيك بالمرة. أنت راح تعطيه أصوات. Just like this is whisper at 1 meter distance. This is quiet home. These sounds, and you just explore whether he can detect these sounds or not. انت هذا بتسوي زي ما بحط لك طبيب العيون بحط لك عدسه يقول لك شايف فيها؟ يقول له لا، بدنا نحط لك عدسه ثانيه صح؟ في الفحص. هو بيعمل ايش؟ examine. Same thing. انت بتعطيه صوت. You can hear the sound? No. You change the sound. This is done by machine. في جهاز يا شباب. انت ما راح عفوا ما راح تصفر له ولا راح هذا. في جهاز بيعطيه اصوات زي هذا ready. So this is like that. And this is your job. إذا حددت أنت in which level he can, you can easily specify which that earphone you can apply for. أي سماعة راح تعطيه. أوكي؟ هذا مش مطلوب منك حفظ بس في وقت هو chart you have to use it. أوكي. تعالوا معي على الأسئلة الآن يا شباب. هذا قانون كثير مهم يا شباب الله يرضى عليكم. هنا راح تلاقوه كيلو. طيب. First of all, a person shouting at the top of his lungs emits about 1 watt of energy as sound waves. What is the sound intensity level 1 meter from such a person? Okay, I'm gonna write only what is given. This is my power. And 1 meter, this is,
We will find the intensity and then we will put it in the B equal log.
see ya shabab. Okay, yes, but I'm the person now. When I talk, my sound distributed in all directions, right? When we say, you can say, this is your 1 meter, or this is 1 meter, backside, or to the left, or to the right. So, finally, you have what we call by something like a circle, okay? Just like now, I'm talking, you can hear my sound. Who's back also, who can hear also my sound. So my sound distributed in all directions. Is that right? That's why they give you 1 level from such a person. From any point, you can step here, or here, or here. All of them is 1 meter. Okay, barakallah feekum. So this is 1 meter is nothing but R, is the radius. Now let's see. Now, what is the sound intensity level? We ask for I. Sound intensity level. Now, I is equal to B over area. B is given, but I need the area.
R squared multiplied by pi.
It's pi, yes, Muhammad, R squared. This is we predict, but it is 4 by R squared. Can you tell me why? We are not dealing, ya shabab, with the shuf ya shabab. I made the same mistake, by the way, first of all. I thought this is a circle. You know the circle is a 2-dimensional. This is the area of the sphere. We have it 3-dimensional ya shabab. يعني لاحظوا بارك. My sound goes horizontal, صح? And goes vertical. This is 2-dimensional. But it goes also front and back. صح؟ لو تخيلت بدك تعمل just 3D for my sound, it distributes not in only one plane, in all the planes 3D, صح يا شباب? So here we know that we use the area of the sphere, which is 4 by R squared. So put this in your mind. This is of course will be given for you. Area of sphere. And we know that B and R is there, so you can directly apply for it. واضح بارك الله فيكم, this is clear? Okay. Now, the threshold of hearing correspond to, I think we answered this question. What is the answer here? Threshold? It's A, 0 dB. Yes, just like him. Okay. Now pay attention to this question. This is the most important question out of all these. You are hearing a very heated conversation that registers 80 dB. You walk some distance away so that the intensity decreases by a factor of 100. What is the sound intensity level now? What is the sound intensity level? Okay, Shabab, I'm gonna try to show it to you. You are hearing a very heated conversation with a register 80 dB, that's sound intensity level, okay, 80 dB. You are walking away from that source in such a way that some distance, that the intensity decreases by a factor of 100. By a factor of 100, it doesn't mean 100. It's a factor of 100. I'm going to explain now. What is the intensity? Of course, the intensity will be less than 80, since you are moving. Okay. If we say, oh, all of them less than 80, so which one of them we can find? While you're thinking, I'll just write what is given in the question. We just only had a shabab I equals, beta, we have only beta equal 80 dB, because dB is 4 beta. From that one, what we can find?
Can find intensity.
Yes, I. Yes, perfect, ya shabab. See what is given here. I told you the formula. Allah yarfa'akum. See, ya shabab. beta is equal to 10, right? Log I over 10 to the power negative 12. I told you, what is unknown is either beta or,
Intensity.
okay, since beta is given, let's go and find I. Let's do it, see it. 80 is equal to 10 log I over 10 to the power negative 12, okay? I'm gonna cancel this zero, this zero. So we have 8 equal log I over 10 to the power negative 12. Finally, what we do simply, we say I over 10 to the power negative 12 is equal to 10 to the power 6. Sorry, 8. 8. Okay? Now cross product times both. 10 to the power negative 12, 10 to the power 8, it will be 10 to the power minus 4. Perfect. Yes, this is my intensity. Now this is my intensity here. But what happened, he told you, it decreases by a factor of 100. This is factor, not 100 a number, by a factor of 100. So if you decrease this to factor of 100, see ya shabab, decrease by a factor 100, it will be 10 to the power negative 6. This is the 100 factor. بعض الطلاب, I made the same thing. But I will make minus 100. No, not like this. The factor of 100, it will be any number it will decrease. You know that 10 to the power negative 6 is less than 10 to the power negative 4. What is the factor between them is 100. From negative 4 to negative 6 is 2 zeros. Right, ya shabab? Now this is my new I. Can I find B now?
Yes.
See, B, it will be, لاحظوا يا شباب, 10 log, I will do it directly, 10 to the power negative 6 over 10 to the power negative 12. I will sum this up. الآن, we have both, راح يصير 10 to the power 6. Log 10 to the power 6, how much is it? 6. So, شايفكم 10 to the power positive 6. صح؟ Log 10 to the power 6 log 10 ايش يصير؟ So what is your answer? It's 60. I know it's maybe a little bit longer يا شباب. بس والله يا شباب, it's a good example. نعم.
It should be log 10 power negative.
Why? This one?
And the another one.
No, we send this up. It will be 10 to the power positive.
I trust the one.
This one?
The point. I trust the one.
No. هذا ليش؟ 10 أس 8. احنا شلنا اللوج. ايش بتحط هنا؟ 10 to the power
8.
صح الله يبارك فيك؟ طيب, is it clear يا شباب? I know it's a little bit difficult at the beginning. If you try this 2-3 times يا شباب, you will be familiar with these questions. الله يبارك فيكم شباب. هذا الموضوع الآن هذا جزء كثير, هذا جزء مهم. So you take care of it. طيب, if that clear, let's go to the next point. You said something about Doppler effect. درستوا ايش هو Doppler effect? You heard about it before? طيب, can you explain it? What is it? أيوة, the observer, we have the source. طيب, see يا شباب, what is the Doppler effect simply? Because we have some application Doppler effect. In Doppler effect, something actually you can feel different frequency than the original frequency. How? If I step outside my home and there is a car with a siren approaching, عندي إسعاف أو سيارة دورية بتقترب وهي مشغلة الإنذار, I feel as the car approaching me that the sound frequency increases. Okay? It will be maximum when it pass in front of me, right? And then when it starts receding, تبتعد, what happened to the sound frequency? Okay, whether the driver of that car, he controlled the frequency, he changed it?
No.
So the frequency is supposed to be constant. Why you feel this change in frequency?
The
Due to the what we call by the Doppler effect. Of course, due to the distance. So I'm going to draw it simply for you first. I'll give you the formula. Then, see ya, Shabab. This is the small car. This is stationary car with a siren. Now here, Allah Barak fikum, you see that waves, they are equally spaced like this. If the car is stationary. واقفة سيارة الإسعاف هذه أو الدورية واقفة وهذا. So we have here يا شباب, here we have lambda same and frequency will be the same also. Okay? Now the second case, when the car starts moving, what happened? The waves in this direction of motion, they will compress due to the motion of the car. So what happened? These waves, they are starting like this. See, in some part, it's actually approaching, and some other part, they are moving space away from each other. لاحظوا, this was equal. Here, as the car moving, what happened to the lambda? So what happened to the frequency? So you are here, you will see that frequency is increasing. On the other side, you are the back side, the car is receding. تبتعد عنك. What you feel about here? Lambda increasing, so frequency what?
Decrease.
This is what we call by the Doppler effect. Simply things. Of course, we can assume up here. There is a stationary observer and moving source, or stationary source and moving observer. يعني ممكن أنا دورية واقفة وأنا بقترب منها. كل ما أقترب منها بسمع إن الصوت إيش؟ يزيد. لما أبتعد عنها فأو ممكن تكون أنت واقف الدورية تقترب منك. صح؟ So the Doppler effect here is the change in frequency when the source moves relative to an observer. Yes, when the source or the observer himself move relative to the source. تعالوا معي الآن يا شباب. There are 4 cases. 2 cases for the observer and 2 cases for the source. I'm going to give you one formula for all of them. ما راح اتبع الموجود في الكتاب. That we can apply for all of them. I'm going to show you. The 4 cases when the observer approaching and when the observer receding. لما يقترب المشاهد أو لما يبتعد. The second 2 cases when the source approaching, when the source receding. There is one formula for all of them. By the way, we used to give this formula last year. Now with this book, they give more formulas, but I want to show you something. The formula states that the frequency that you feel, I'm going to call it F, is equal to, see V plus or minus, V minus or plus, V of the source times F, we say, of the source. I will explain this for you. Got this. First of all, this is actually the field frequency, not what we feel. And this is the actual source frequency, right? هذه يا شباب frequency بتاعت السورس عندنا. Your V is the sound wave in air. Mostly هذا بيكون ثابت 343. VO is the speed of observer. سرعة المشاهد. VS speed of source. How we deal with it? ركزوا معي يا شباب. انتبهوا معي هذا. This formula, if you know it, it will help you instead of using 4, you can use only 1. راح أعطيكم حاجة. If we say the following case, if we have stationary observer, لما يكون يا شباب مشاهد واقف، واحد من هذول راح يكون 0، ايش هو؟ VO، صح؟ طيب ايش بصير القانون؟ انتبهوا معي. As stationary here, if we have stationary observer, we know VO is equal to 0. طيب VO is equal to 0, so F is equal to V over V minus or plus VS times FS, right? شباب, what you need only, the frequency of the source and the speed of the source. الفي هاي راح يعطيك اياها، الفي ترى سرعة الصوت في الهواء 343 هذه الفي ثابتة هذه. عرفتوا علي؟ طيب we have two cases minus or plus. شباب minus here when the source approaching راح اوضح لكم اياها. source approaching. طبعا plus when the source ايش؟ receding. راح اوضح لكم ليش. When the source approaching, what happened to the frequency? Increase or decrease? Increase, صح؟ Let me show you. We talk mathematically. ركزوا معي بالmathematics. لو سمحتوا. إذا شلنا السالب يعني هذا السورس قاعد يقترب. طيب شباب 340 تقسيم مثلا 100 340 ناقص مثلا 240 القيمة راح تكون هذه أكبر من واحد صح؟ فممكن نقول دخلنا نعطي أرقام عشان راح تكون مثلا 340 over 340 minus 2 مثلا نقول 140 الجواب راح يكون يا شباب في النهاية 340 divide by 200 صح؟ هل هذا أكبر من واحد ولا أصغر من واحد؟ إذا راح تكون عندنا يا شباب F is equal to suppose 1.6 Fs. إيش تفهم من هذه العلاقة؟ Which is bigger? F or Fs? أنا سألت زملائكم الأكبر إنه هو هذه يا شباب. F أكبر. F يساوي 1.6 times F of S. صح؟ What you feel is greater than the original one. هذا الأوريجينال يا شباب. What you feel is bigger than. انتبهتوا علي يا شباب؟ طيب. The second one, if it is positive, ركزوا معي نفس الجواب ها نفس الإقامة. راح أحط أنا هنا positive. اللي تحت كم راح يصير يا شباب؟ 480 صح؟ 480 is less than 340. الجواب راح يكون أقل من واحد. فمثلا يقول الجواب عندك F is equal to 0.8 F of S. مين أكبر الآن؟ F of S أكبر. صح؟ And this is what we need. والله يا شباب see. All what you need this one only. If you can deal with it, it's easily. And you see. Now, plus, pay attention. The observer approaching minus the observer receding. Here plus the source approaching and minus and plus the source receding. That's it. Not more than that. عرفتوا علي بارك الله فيكم. Now I'm going to show you something what they give you. لاحظوا أعطوكم قانونين. Approaching source. طبعا راح أثبت لكم هذول كمان من قانوننا. بعدين بعدها شوف يا شباب راح أتكلم عن هذا. أعطوكم another two formulas. أنا ما بدي إياكم تحفظوا الأربعة. تعامل مع واحدة يا شباب. You deal with it. الحين راح أوريكم حاجة what they give you. راح يقول الدكتور إيش بيعطينا هون معلومات. انتبه بارك الله فيك. See يا شباب. This one receding source صح؟ receding source. طبعا receding source احنا عندنا هنا the moving source إذا the observer stationary صح؟ V O equals 0. تعالوا معي نقول F is equal to V over V minus or plus Vs times F of S. احنا قلنا receding source راح تكون هذه plus اوكي؟ احنا approaching receding يقترب يبتعد approaching receding ركزوا معي شباب. Is this one similar to this one? طبعا yes. I'm just going to show you to you. يا شباب انظر بارك الله فيك. اقسم البسط والمقام على V. ايش بصير فوق؟ V over V. هنا V over V1 plus Vs over وفي عندنا what؟ الF of S خارجة. We got the same equation. صح؟ We have nothing about this. طبعا Fs ضربها ممكن ندخلها. We have the same equation. أنا بعطيكم إياها this equation يا شباب instead of using 4 different equations we can use only one equation and we can do the modification to it. This is double. I think it's also important in problems. راح يكون في عليها مسائل يا شباب من ال problems. طيب is that clear for you بارك الله فيكم؟ Well, we have 4 cases. والله يا شباب نوضح هذه النقطة بسيطة جدا يعني. وإذا حبيت تكتب قانون أنا بحاول جهدي إني أعطيكم قانون حتى في الامتحان زي هيك. Approaching observer, receding observer, approaching source, receding source. يقترب ويبتعد اللي هو الأوبزرفر المشاهد، يقترب ويبتعد اللي هو المصدر السورس. That's it. This should be given for you and this should be given for you. واحد منهم راح يكون دقة معنا ايش؟ Zero. Either observer or the source. طيب. Now we have some now concept which is called by the shock wave. سمعتوا عن هذه يا شباب كلمة shock wave؟ طيب. Sometimes some we can say devices or machines they can move with a speed greater than the speed of sound, greater than their waves, produce wave. At that one we call these as a shock waves. Mainly يا شباب this is happening in water. ترى بالمناسبة سرعة الماء ضعيفة جدا. لو تحركت بسرعة تعمل شيء اسمه انت shock wave. Sometimes يا شباب air fighters طائرات الحربية you can see the air fighter first then you can hear the sound. So it's moving faster than its sound. So it produces something called by the shock wave. انتبهتوا على الفكرة؟ Now I'm going to show you some here footage on this. راح أوريكم حاجة. We have here شباب some images I need to show it to you. This is what we call by the shock wave. You see this is a very fast here. Fighter can simply move faster. This is, we assume that this is its sound and it's moved a little bit ahead than the sound. Now you see, I'm going to show you something here. We have one more point. This is the sound, the waves produced by the plane or the fighter. This is when it is stopped, it's actually have this sound. لاحظوا يا شباب, all of them, that lambda here is the same as lambda. So the frequency in all directions the same. Now, when it is moving subsonic, there will be, this is the direction. So well, lambda here will be less, so lambda here will be more, and this is normally, so the frequency increasing. Now this is called subsonic. تحت سمعي يا شباب. This actually you cannot hear, it's moving very slowly. Now it's moving to the limit in the same speed of sound. Suppose the speed of sound 340 is moving 340. This is called the شباب speed of sound, which is called by the sonic. هذا سمعي, للسالفة سمعي. And if it is moving faster, supersonic. لاحظوا شو? What happened? This overlapping is due to the what we call by the shock waves. لما يصير عندنا شباب لاحظوا هنا. This is normal. This is actually what we studied in Doppler, صح? This is something more. It's actually exceeding the limit. واقفة على الحد هي. ليش؟ لحد الآن نسمعها لكن ماشية بنفس السرعة. Here it's exceed that limit. So it's produced what we call by the supersonic. Nowadays, شباب, we have cars or airplanes. Sometimes they are actually move in what we call by the supersonic region. في عندنا الاير فايترز كان في طائرة شباب مشهورة جدا فرنسية الكونكورد إذا سمعتوا عنها وقفوها. هذه الكونكورد كانت تقطع المسافة بين نيويورك للندن في ساعتين بينما هي طبيعي تنقطع تقريبا 7 ساعات تقطع محيط كامل. Why? Because it's moving what we call by the supersonic. This is the idea. So this is what we do. Now let's go back to the Doppler effect. I'm done يا شباب, just وقفت أنا ما في عندي بس حاجة بسيطة. Why we study the Doppler effect and what is the relation with the Doppler effect with the math here with the medical applications? Follow with me يا شباب. Ultrasonic waves reflected from red blood cells can be used to determine the velocity of blood flow. if you know the velocity of your patient flow, you can easily detect what the problem he has. If whether the flow is laminar or turbulent. I told you. لقياس سرعة ترسب الدم يا شباب أهم شيء إن نقيس إحنا إيش what we call by the Doppler effect. We use it. Something more also sophisticated. Reflection of ultrasonic waves can also use to detect the movement of chest of a young fetus here and to the motion of its heartbeat. الجنين الصغير اللي بيكون عبارة عن كيس حمل صغير جدا في الرحم. How it's the motion and how it's starting here, it can be used also the ultrasonic. There is no type of imaging you can use it. ما تستطيع يا شباب انك تصوره. This is very delicate, very sensitive. تعرف الحامل ما بتتعرض لأشعة. صح؟ So this is also used in ultrasonic. We use also Doppler effect in that one. That's why we need it. We need a lot Doppler effect. Alhamdulillah, you are going to figure the idea is what? Here, we have waves. We simply focus the wave on something, and we receive the reflected waves. That's it. And you can see what is actually the velocity from that one. Now we have one more point. This is it. See, Shabab. I think now all of us will be familiar with this one. With the radar is the working on the Doppler effect also. The car that patrols the car simply sends waves toward the normal cars, and the wave will reflect back and detect. This here reflection shows what is the velocity or the speed of that car. And I want to say something, Ishbab. You are dealing with a moving sources. يعني أنت بتوجه على شيء متحرك, صح? That's why this is taken in considerations, and this is why we need it. By this way, you can detect the speed. بهاي الصورة يا شباب. Just like what? See, شباب. Sometimes if you wanna actually go for hunting birds, you use guns for that one. If there is a group or herd of birds, كان عندنا مجموعة من الطيور طايرة في السماء. معك أنت بندقية بدك تصوب عليها. أنت ما بتصوب على الطير نفسه. تصوب أمام الطير. قدامه ممتاز. ليه؟ طيب وهذا بالمناسبة هذا moving source. لأنك يا شباب لو صوبت على الطير لما توصل للرصاصة راح يكون تحرك في مكانه, صح؟ وهذا بالمناسبة this is estimation. أنت تحاول مع الخبرة إنك تعرف وين تطلق الرصاصة بالضبط. نفس الحاجة. This is we have estimation of that one. And that's why we use Doppler effect to detect here. Nobody can, يا شباب, here simply measure your blood speed inside your body. No one can see. But in this here, ultrasonic sounds, using Doppler effect, we can do it. هذه الطريقة يا شباب تقيس لنا البلد بشكل رائع. انتبهوا يا شباب. Speed or velocity of blood indicates a lot of problems. حسب سرعة الدم، ترسب دم، انت ممكن تعرف ايش بريضك عنده من ايش من مشاكل تتوقعها. لأن لما يكون عنده إنسان مشكلة، الطبيب ما بيقول له والله على طول ادخلوا على العمليات. بيعمل له فحوصات لمدة سنة كاملة. حتى يتأكد إن المشكلة محصورة وين؟ في هذا الجزء. بعدين بحدد له ايش؟ يعني مثلا يا شباب أول شيء بيقول لك والله ايش عنده مثلا انسداد في شريان من هذا. هو ما اكتشف. خلينا نقيس سرعة ترسب الدم. خلينا نعطيه مميعات. خلينا نحسب له مثلا اجهاد القلب عنده. نحسب اشياء ثم نعمل له MRI، نعمل له اشعه مقطعيه، ثم بعد ذلك والله بنعمل له قسطره، عمليه بسيطه. لاحظ بعد ذلك والله ما نفعت معه، في الاخر ايش؟ نعمل له جراحه قلب مفتوح. تخيل العمليه هذا بروسس takes 2-3 years في الغالب، ما بتاخذ يوم يومين. لانك ما حد راح يسمح لك والله تقول له صدري بوجعني، يقول لك الله عمليه قلب مفتوح. يقول لك هذا ايش هذا؟ خرفان احنا؟ صح يا شباب؟ This is natural. You are going to learn this step by step. انتوا راح تتعلموا هذا الشيء. ما في راح تمشي مع هذا بريدك وتفهمه. We will try this first. ترجع لي بعد شهر كيف شايف نفسك؟ بعدين تعطيه اجهزه يقيس ضغط دمه، يقيس مثلا السكر، يقيس كل حاجه، بصير يعطيك القياسات. بعدين بتجرب شيء اخر، بتعطيه مميعات، بتشوف ايش صار معه، بعدين كذا، بعدين كذا، بعدين في النهايه تقرر. طيب الله يعطيكم العافيه، انتظروني لحظه.